is responsible for the sense of smell, and that is what we call olfaction. We all know that we smell with our own nose. In the nose, you are all aware that the nose has, walls. It has lateral wall, medial wall, it has floor, and then it has a roof. So in the roof of the nose, the roof is lined by what we call olfactory mucosa. That olfactory mucosa contains millions of these olfactory cells. You get it? So olfactory cells, receptors, are there in millions in the roof of our noses. So the olfactory nerve fibers, each of these nerve fiber is a bipolar kind of neuron. Bipolar in the sense that it has its own cell body, and then it has two main axons at each of the poles. And that is what we call a bipolar kind of neuron. So the olfactory nerve fiber is a bipolar kind of neuron. Each of these nerve fiber now, at the end of its own axon facing the nose, has a lot of cilia. Cilia in the sense that these cilia are the ones that receive the odorants. When we talk about the odorants, we're talking about the different kind of materials that can give sense of smell. For example, perfume, like maybe food, maybe urine. It also smells. Anything that can smell, it can give an odor. That is an odorant. So the nasal mucosa is able to sense about 10,000 kind of odorants. We can only appreciate maybe not more than 10, 20 odors around us, but not knowing that our nose can differentiate thousands of these different categories of materials that can give odor. So more than thousands, 1,000, 10,000 of them. So this nasal mucosa is able to understand such kind of odors as a result of these, olfactory cell receptors. So in the nasal mucosa, we have about 3 different categories of cells that are in the nasal mucosa. This, as I said before, we have the olfactory receptor cells that are carrying the odor, the sense of smell, through the nerve fibers, and we also have supporting cells. These supporting cells are responsible for supporting the olfactory cells in the nasal mucosa. So it means that they give these olfactory cells nutrition and also maybe support, just like the connective tissue cells supporting these neuronal cells. We also have basal cells. These basal cells, they are the progenitor cells. They are all interspersed in this nasal mucosa around the olfactory receptor cells. Okay? So the basal cells are the progenitor olfactory cells because they are replaced, every minute or every second. Some of these, olfactory receptor cells are being replaced from these basal cells. So now we have these cells in the nasal mucosa. So each of these olfactory receptor cells, as it carries these odors from our nose, the fibers, they tend to unite and get out of the nasal cavity into the cranial cavity through the cribriform plates. In the cribriform plate, if you can remember, we have some holes in the cribriform plate, about 9 to 10 on either side of the crystal guide. So it is through this cribriform plate, these nerve fibers, they now ascend up, So it means that olfactory nerve is not only one nerve. It has a lot of fibers, about 9 to 10 fibers, bundles of fibers going out of the cribriform plate, and then they now go and form what we call a bulb, what we call olfactory bulb. So it is the synapsing of these bundles of these olfactory receptor cells from the nose. As they get out of this cribriform plate, they now combine together to form this olfactory bulb. in the olfactory bulb there, these olfactory receptor cells, they also find other cells, what we call mutual cells and tufted cells. These mutual cells and tufted cells, they are also bipolar in nature. So they synapse with these olfactory receptor cells coming from the nose. So they synapse with each other. So it means that each of these olfactory nerve fiber synapse with either the mutual cell or tufted cells or both. Are you clear? So each one of them now synapses with any of these or all of them. So at the end of the day, when you have a conglomerate of this synapsing of multiple olfactory receptor cells together with mutual cells and tufted cells, they form a round structure within the olfactory bulb. So you have a lot of bulbular or globular structures in there as a result of this synapsing of these olfactory cells and the tufted cells and what have you. Each of these conglomerate of synapsing cells is what we call glomerulus. I'm sure you can remember glomerulus in the kidney. So here we have glomeruli. So we have a lot of glomeruli resulting from the synapsing of these cells with the cells within the olfactory bulb. After this synapse, the mutual cells, the axons of these mutual cells, they extend backward, toward the back side of the frontal lobe. So they now go at the base of the frontal lobe, and so as this olfactory nerve, these mutual bulb fibers, as they extend towards the back side of the olfactory of the frontal lobe, they form a tract, what we call olfactory tract. So this tract, as it approaches the junction between the base of the frontal lobe and the base of the temporal lobe, so each tract on either side, because there are two olfactory tracts, one on either side. So each one divides into two major divisions, what we call lateral olfactory striae and medial olfactory striae. So we have this as our lateral olfactory striae and this one as our medial olfactory striae. So this lateral olfactory striae, it is the one that goes into the what we call olfactory cortex, what we call the piriform cortex, which is responsible for all this, interpretation of the sense of smell that we smell from our noses. So these axons from this, lateral olfactory striae, they go to this primary olfactory striae, and so some of these fibers, they go to uncus, some they go to amygdala, some they go to the hippocampus, some they go to the entorhinal cortex. But at the end of the day, the major function of this, traveling of these fibers to these different categories of areas in the olfactory cortex is number one, to receive the sense of smell. Number two, to process the sense of smell, that is to analyze and recognize the type of the smell. And finally, to store that sense of smell into memory and probably to make any emotional expression as a result of that sense of smell. For example, now if you bring something to my nose, something that is very nice in terms of the smell, I smile, right? So I express my emotion. And if it is something that is bad, I winked, or I frown my face. That means that odor is no good. So I also make that expression. So you are aware that our amygdala is, mainly for that purpose, to express, emotions, because it is part of the limbic system. So expression of emotion as a result of olfaction, it goes into the amygdala. Once this one goes to the hippocampus and the entorhinal cortex, it's something to do with memory when we discuss that our papier circuit and what have you. So emotional aspect of smell, the memory aspect of the smell goes into the hippocampus as well as the entorhinal cortex. You know, some of these fibers also extend in the midline, what we call the intermediate olfactory stria, and that one goes to what we call olfactory tubercle. You get it? So all this, you know, are termed as either primary cortex, and it's around this side, and this one, the medial olfactory stria, you know, as I discussed before, this one goes to the opposite side through what we call the anterior commissure. So here you have your anterior commissure here, and so it now goes to the medial olfactory stria of the opposite side. So it means that olfaction is bilateral. That means if you close one nose like this, you can smell with the other one, and you can perceive and interpret and make recognition of that smell. Also vice versa. So that is the essence of this. And so there are, you know, kind of, you know, diseases or conditions that can affect the olfactory nerve. These, you know, conditions like maybe trauma, when somebody has a road traffic accident and he or she fractures the base of the skull around the, you know, cranial complex, this where these nerves, you know, get out of the nose. If these nerves are damaged, that means that person may likely be unable to sense any smell anymore. And so the absence of, you know, sense of smell from that person as a result of that injury, that is what we call anosmia. So if you are not sensing any smell anymore, you know, if I bring maybe a rope or a perfume or anything that is smelly, and you cannot recognize what type of smell is that one, so that means you are anosmic. You are anosmic in the sense that you cannot recognize that smell. So, and that can be transient or permanent. Transient, that means it may be temporary. For example, when somebody has catarrh, you know, the catarrh now, you know, in the nasal mucosa, there is also mucous glands. I didn't discuss it because that is not what we are discussing, but that mucous gland is what we call Bowman's gland. That Bowman's gland is also interspersed along the nasal mucosa, and so when somebody is being infected by this Bronchiomyela catarrhalis, the one that causes catarrh, so it secretes a lot of mucus, and that mucus now comes and block all the cilia that will carry the odorants, so that at the end of the day you will not be able to smell anything, because the mucosal plug covers this area where the odor can bind and make a sense of it. Are you clear? And so by the time you start taking drugs, those mucus, if it is thick initially, is going to be watery, so that it starts dropping out of your nose. And so you start sensing the smell. You smell, you know, sense of smell will start to come back. So that's a transient kind of anosmia. If it is permanent, that means all these nerves, you know, have been damaged bilaterally. If it is only one side, yes, you are lucky. The other side can still function. But if it is bilateral, that means you are going to be permanently anosmic, and so you will not be able to recognize any sense of smell. So also hyposmia. That means if you still sense smell, but your sense of smell is reducing. That means if your sense of smell before it was normal, but later on you start, you know, feeling, you know, less of any of the smells, that is what we call hyposmia. That means there is reduction in the sense of smell. Or what we call hyperosmia. That means the sense of smell is increased. Something that is very, you know, the smell that is very little, but it is exaggerated in your nose. So you feel as if it is the whole, you know, the whole environment is, you know, is like that, you know, kind of smell. After all, the sense of smell there, the smell is very small. So the smell is exaggerated. That is what we call hyperosmia. This one happens in people with what we call epileptic attack. Are you clear? So we also have what we call pyrosmia. Pyrosmia is like you are not able to differentiate between the bad and good odor. For example, now I bring shit and perfume and I place the two together. You will not be able to differentiate which one is having a bad odor or which one is having a good odor. So you are not able to differentiate. That's what we call pyrosmia. There are diseases that also cause that. And there's also this dysosmia. It's about difficulty in, you know, understanding the sense of smell. You get my point? Understanding this, you have difficulty in knowing what kind of odor is this one. So you are not able to recognize per se, but you are smelling that odor, but you're not able to, you're having difficulty in knowing exactly what it is. Are you clear? So there are some diseases that can cause either of this, like Alzheimer's disease, you get it, that one can cause, even other diseases like Parkinson's disease can also cause something like this. Epilepsy can also cause, trauma, cancer of, the cranial bones, the bones in the base of the skull, if there's cancer there, something like that can cause, this kind of diseases. So we are going to have a break now, and then we continue with the second cranial now.